I would like to warmly welcome Manish Parashar. He's the Office Director of the National Science Foundation, Office of Advanced Cyberinfrastructure. He's the Director and Chair in Computational Science and Engineering at the Utah University Scientific Computing and Imaging Institute SCI. He's a AAAS, ACM, and IEEE Fellow. He's leading the development of NSF strategic vision for national cyber infrastructure ecosystem that has already had a big impact on our community and will guide NSF's future CI investments. And you saw many of the blueprints that came out from NSF thanks to Manish. So today, Manish will give NSF's perspective on cloud computing and other topics on his mind. And it's really, truly a pleasure and privilege to have you here, Manish, with us. Welcome. Thank you.
Thank you, Eva. And this is fantastic. I'm doing this after 2 years. I still hope I remember how to do this. The good news is I don't have to remember to unmute myself. The bad news is you cannot mute me. At least some of you cannot. Anyway, this is really important, right? Large facilities, major facilities are really close to my heart. I think they're tremendous investments. We're lucky to have them that can have really fantastic impact on science, research, education. And I think CI Compass is just doing a fantastic job. So I'm really, really happy to be here. I started off trying to talk about cloud, and I figured that I'd like to broaden it a little bit. And so I'll touch on clouds along the way. But I wanted to really focus on democratizing science to advance cyber infrastructure. And I think facilities is a big part of that. So here is a outline of my talk. I'll give you a quick overview of just to remind you about, that should have been NSF, sorry, about NSF and OAC. And then there are really two things I wanted to focus on here. And the goal here is to start some discussions. I'll talk about what we are thinking. And then I'm hoping that we can discuss that a little bit. The first one is on trying to democratize access to national cyber infrastructure ecosystem. We have a very rich cyber infrastructure ecosystem that we have really funded through the past many decades, right? And so how do we sort of make sure that that can benefit everybody? And the second piece of this is some perspectives on major facilities cyber infrastructure. And the goal here is to maybe try to get on the same page. I thought Peter's question was very, very valid right now. So what is cyber infrastructure? And then I put out some questions. I'm hoping that seeds some discussion, but let's see where that goes. So let's start with the first. Okay, so a couple of years back now, we had a new director join us, Dr. Panchanathan, right? And so he built on the mission of NSF. And if you've heard him talk, he really gives meaning to the word speed and scale, right? He's all about growing and accelerating NSF's impact. And he really recognizing the current challenges, the current focus areas, priorities. He really tried to add to the overall mission an emphasis on people, partnerships, and translation, right? And really, if you've seen what's been happening in NSF, is really trying to move these themes forward. So, see if I can do this. Give me one. Anyway, sorry. So here are some of the priorities that you can see for FY22 at NSF. Enhance research and development, so really support the spectrum of science, engineering, technology, and education. strengthen US leadership in emerging technologies, right? This is something that you might have heard a lot about. This is around creating a new directorate that's focused on technology, on innovation and partnerships. And this is something really different for NSF, right? This hasn't happened for a long time. I think the last new directorate was SIZE, right? So the idea here is to recognize that technology has a broad impact, and you need these cross-cutting structures that can take foundational research, use-inspired research, and move them so that they can really have impact on science and society. And we need to do it in a thoughtful, structured way, and that's sort of the focus here. Advance equity in science and engineering, how to increase participation. You hear him talk about the missing millions, right? That's really how do you bring everybody to the table so everybody can benefit from these investments, from these opportunities. Advanced science, climate science and sustainability, aligning with the administration's priority. How do we advance these along different dimensions? And advance the forefront of infrastructure, and that includes cyber infrastructure, but also infrastructure around NSF's research facilities, right, which is the focus of this meeting. Just to emphasize the point of this new horizontal, right? So we have the standard NSF 7 directorates, and so how do we create these cross-cutting structures that focus on translation, that focus on technology and innovation, and in partnerships, right? And this is integral across. If you look at the FY22 budget request that NSF submitted, or even the conversations going on right now at the Hill, whether it's USICA, whether it's competes, right? You'll see that this new directorate, the TIP directorate, as we're calling it, but has different flavors, but is part of all those conversations moving forward. So this was a quick overview about what's happening at NSF. I just wanted to remind you about OAC. You've heard me talk about this many times. So NSF's Office of Advanced Cyberinfrastructure is an office. It's housed within the SIZE directorate, but being an office, it has a NSF-wide mission. So it works with all the other directorates and offices to advance their mission by providing two things, by providing, by really helping transform science and engineering research and education by providing production research cyber infrastructure. That's right. But also investing in innovation in cyber infrastructure research that continues to innovate in and advance the cyber infrastructure itself, right? We view cyber infrastructure broadly. Clearly, there are the computing systems and the networks, but increasingly clouds are a big part of the cyber infrastructure. Services, whether it's data services, coordination services, are a big part of it. Software and data stacks, software stacks, right? Data infrastructure, test beds, coordination capabilities, gateways, right? And most importantly, the expertise, the people that make up the cyber infrastructure. A big focus in the last few years is recognizing that we have to invest along each of these verticals, right? But they have to work together, right? Science only happens when all these pieces can work together, when the computing and the networking and the data and the software and the people can come together to really advance the science workflows. So while we have continued to invest in each of these areas, we have also invested on making sure that they can be integrated together, that they can be tied up to advance the science. The second thing that we have recognized and really focused on is the fact that research needs, application needs, but also the technology landscapes are continuously evolving, right? So that means two things. That means that we need to continue to innovate, understand what these new requirements are, and evolve our cyber infrastructure ecosystem to meet those requirements, to really leverage these new opportunities that technology advances gives us, but also make sure that we are meeting the needs of the application community, whether in the new types of science application formulations, science opportunities they have, but in new ways of using this infrastructure, right? As researchers come in, they want to engage or interact or leverage the cyber infrastructure in different ways. So how do we continue to evolve the cyber infrastructure? It's been a couple of years now, but we did put out a vision, and that sort of laid out how we want to do this. What were the key overarching principles guiding our strategy, whether it is, as I mentioned, viewing the CI more holistically, coming up explicitly mechanisms for supporting the translational research needed to take innovations and translate them into production cyber infrastructure, being able to balance innovation, which has to happen continuously, with the stability that scientists need to do their science, right? So how do you make sure you balance the two? How do we couple different discovery innovation cycles? And most importantly, how do we make sure that the research community, the science community, can use this in an effective way? How do we improve usability? How do we provide the right support services so that the cyber infrastructure can be used as broadly as possible? Complementing this, what we've been doing is to say, okay, how do we implement this vision in each of our dimensions of the cyber infrastructure: computing, networking, services, software, workforce? So we've been putting out blueprints, which is really a starter for a conversation with you. Right here said what we are thinking. Does it make sense? What is your feedback? And as this evolves, we then translate it into programs and solicitations that you can respond to. And you've seen that happen in a number of cases. And the overarching reason why we do this is all in this slide, right? This is some of the science that has been enabled to cyber infrastructure in the past few months, right? And this is just a sampling. There's a lot more. I'm not going to go through all of these, but it just highlights how different innovations, whether it is advanced computing resources, whether it's new type of algorithms or software services or data services, whether it's new types of expertise in training, right? How they can come together to address really important, societal important, very timely challenges, whether it is, how do we deal with supply chains or a certain weather patterns, or how do we board an airplane in times of COVID, right? Very timely problems that these different investments can come together to address. So with this quick overview, I wanted to just throw out some ideas. Again, this is a work in progress, things I'm thinking about. We are thinking about it at OAC, right? How do we democratize access to national cyber infrastructure, right? And that, we've invested in a lot of capabilities, whether it's capacity system, whether it is services, whether it's software expertise, but there remains a gap between folks who use this and use it very, very effectively, and a broader community that struggles to use it effectively, right? So how do we address this, and what would be the next step to do that, right? Just to give you an idea of the diversity of the ecosystem that we have been creating, this is just a sampling of our computational capabilities. They range from leadership class systems such as LCCF. Frontera is phase 1. We are working towards phase 2, which is going to be a large computational facility, which means it's a computing system, but a lot more than that. We have the capacity systems that provide a diverse set of resources, whether it is large capacity systems, or whether it is Expanse's example, a large memory system, for example, bridges. We have cloud-like systems like Jetstream. We have Anvil, and you see them all on the slide, right? So the very diverse set of capabilities that provide systems resources across a broad set of user communities. Increasingly, we've been trying to fund experimental systems which try out new technologies, new architectures, new type of processors. And the goal here is to see, are they useful from an application perspective? And if they are, how can we incorporate them into our broader production ecosystem? And this includes systems such as Okami, which leverages the investment in Fugaku in the Japanese exascale program, and the Fujitsu chip. We have NeoCortex, which is the Cerebrus wafer scale AI processor. We have Voyager, which is based on Intel's AI chipset, the Habana, right? So there are other systems such as the National Research Platform. We have ACES, right? So we're trying to look at different architectures, different ways of thinking about computing, right? And the goal is that let's look at them, let's try to evaluate them in the context of real science. And if they provide value, let's incorporate them into our ecosystem, right? But this is not it. Oh, I should mention, in addition to that, we have the PATH OSG project, which not only leverages this system, but then leverages campus level investment, for example, to the CC Star program, and brings them together, right? So to be able to provide federated capacity for high throughput workloads across the community, right? So the goal here is to provide a diverse set of resources that can meet the growing capacity across the broad community of science users, right? But this is not it, right? Our ecosystem is much broader. We have test beds, Chameleon, Cloud Lab, Power, Fabric, and so on. We have software services. We have data services. We have expertise, right? So it's a huge, diverse set of capabilities, right? But when you look at it and think of it from the user's point of view, right, it is also very daunting, right? Which is the right resource for me? How do I get to it? How do I write a proposal to get an allocation? How do I use these together, right? And you often ask folks and say, okay, it's, you know, I'd rather use something local because this is just too complex, or it's not for me, right? So how do you leverage this broader ecosystem, right? There was a very interesting study, and it's on the next slide, led by Alan Bletekian team, called the Missing Millions Report. And they really talked to the community and said, you know, what are the barriers to access, right? Why don't you use NSF resources? These are there, these are tremendous, right? Why is it that, right? Why is it that it's hard for you to use? And I really recommend reading that report. But, you know, I just pulled out 3 aspects that were highlighted in the report, right? Often it is discovery. You don't even know that these resources are out there, right? So how do I discover that I have these resources and I can get access to, right? And once I discover them, how do I get access to them? The barrier to write a proposal may be too high for all users, and they may not need to, right? If I just need a certain set of, you know, I don't want large dedicated time, maybe I don't need to write a proposal. Can I get immediate access to it? Right, so there's a URL down there, allocation, right? Right now there is a pretty, in most cases, there's a high barrier to entry in writing a proposal, getting evaluated, and there's a time lag, right? I get my project funded, I have to wait for 6 months before I can get onto a system, right? And for some cases, it does make sense, right? If I want to do a very large run on a large system, it makes perfect sense to think about it, make sure that these are, but in many cases, maybe we need to have alternate approaches. Maybe I want to do something that is quite urgent, right? I'm responding to an urgent event, right? How do I get on-demand access or urgent access to resources? And facilities is a great example. You never know what your next observation is going to look like, right? And that might need you to do something immediately, right? You cannot wait 6 months to do this. So how do we create ways to broaden our access? Can we provide cloud-like on-demand access as well, right? So how do we broaden our allocation so that everybody can get access to it and really build on the mechanisms we have? And I think the most important is the last part. How do we create a scalable model to support our science community, right? It means providing support at the campus level, at the regional level, and at the national level, right? So how do we build a framework? So what I'm going to do over the next 2 or 3 slides is give you some examples of some baby steps we have taken to address these. And the idea is to get some of your thoughts on what we can do. But we've just started trying to come up with ways to address this, right? So I'm going to try to take each one of these one by one, right? So the first one is access, right? Can we make it easier for users to access, right? Can we think about, envision a single portal? The user comes in using some type of a assistance, whether it's a recommender system, whether it's a human, right? Tells them, okay, you know, for this kind of workflow, you might think about these resources, right? They can get access to them, they can compose their workflow and deploy it from that, right? So we have a lot of technology, there's a lot of research that enables that, but from a production infrastructure point of view, that doesn't exist today, right? And just the benefits, right? So some of you might be familiar with the COVID-19 HPC consortium, right? This was something we stood up, and it's quite amazing, right? We stood it up in a week in March of 2020. It seems a long time ago now, but this was when the pandemic was, the impact and the extent of the pandemic was becoming clear, and we realized that computing has to play an important role. A bunch of agencies with industry, academia came together and said, let's try to create a common entry point and to provide immediate access to resources, right? So it was something like 600 petaflops of aggregate computing power across the providers was made accessible. Folks accepted simple requests and decisions were made in a week, and people were immediately given access to the resources. So it was just incredible. Even though it came together in an ad hoc way, the impact of having such a unified access mechanism was clear from that, right? And so the idea is, how can we then learn from that, learn from a lot of the other efforts that have been done to be able to create this access abstraction, right? So what we've done is to say, let's try to pilot this. Let's see what we can do with the technology and solutions we have. So we partnered with Pilot. Frank is here. I guess Miron should be online, right? And said, okay, you know, we have these resources and we have a path, which is a federation. Can we use path as a way of allowing a user to use their allocations on the differences? If I have a credit card on Amazon, can I use that? If I have an allocation on CloudBank, can I use that? Can I put it all together, launch my workflow to a single portal and let it run appropriately across this network of resources, right? And so that's just an example of what could be done, viewing that entire diverse ecosystem of resources as a national research cloud, right? And this is just a graphic that sort of tells you what it is. And I'm sure Frank can talk more about the science that's being done. But you know, you have a single access point. You come in, right? You use your allocations that you have. You specify your workflow, and then it automatically gets mapped on to the right set of resources underneath, and this set is growing, right? But for a certain class of jobs, in this case, it's the high throughput computing jobs or workflows, this is a nice way for users to access it, right? Again, in most cases, you may not need an allocation, but if you have one, you can use it. But it's one way to start bringing this vision together, where users don't have to know about each resource, have to log into each resource, launch their job using mechanisms that are unique to that resource, but you have a single entry point, right? In terms of allocation, and some of you might have seen our Dear Colleague letter that came out last week. So far, the most dominant way of accessing or getting allocation was to write a proposal as part of LRAC or previously PRAC or XRAC processes. You write a proposal, they get evaluated, and you get an allocation, right? So we're trying to pilot and see what happens if I can couple the allocation with the research proposal evaluation, right? So here's how this works. When you submit your proposal, you add a page or two, I'm not sure what the specifications are, that describe the resources you need, right? These get evaluated when your proposal is evaluated. And when you get, if you get awarded, you get a notion of some funny money or credits. You take them to PATH, and then they can be translated into access to any of our resources, whether it's Stampede, whether it is Expanse, whether it's a cloud lab, right? It gets, and then you can run it, right? So A, you don't have to wait. B, you don't have to write a second proposal. And it's a more flexible way to get access to these resources, right? And so again, we said, let's start piloting this. We started with CSSI, that's our Software and Data Services program. And when we started talking around the foundation, everybody wanted to come on board, right? So now we have 14 programs, it's growing. It just makes sense, right? Now, this is not going to replace the big allocation. Sometimes you do need those, but this is an alternate way to access resources. Again, make it easier, right? And so we are exploring other ways to do this as well. I want to spend the next couple of slides talking about support, because I think that is the hardest thing, right? How do you build a scalable model to provide support across the broad set of users that has certain integration, but is also very responsive to the local needs at the campus level, right? And so I'll talk a little more about two things. One is the blueprint that we have, which sort of starts outlining a strategy out here. And then the second one is the access solicitation, and I'll have a slide on that as well. So a central point or central piece of this support solution is what a community broadly we have termed as CI professionals, right? These are the software, the data, the systems experts that are just critical to doing science in the 21st century. Often they're not recognized. We don't have the right academic structures to support them, right? So this has been a challenge. I remember the first time I appreciated this was at the 2017 CI for large facilities, the Major Facilities Workshop, right? I think everybody had their challenge, but one cross-cutting theme was, how do we recruit? How do we retain? How do we train them, right? How do we make sure that, you know, even though we have these great passionate people, how do we make sure that they're not being attracted away by Amazons and Googles because they're just so talented, right? So these were the questions that came out, and this is something that we've been thinking about, right? How do we promote professional development? How do we incentivize universities to really think about their professional development, their career paths? How do you establish and nurture a community of these, right? They are a minority within a single project, right? But if you look across the projects, we have a rich community. How do we foster and nurture that community? And then how do we help universities, academic institutions to support their career paths? Eva, you should let me know when I'm running out of time. So here are some things we're doing, again, baby steps, right? We have started requiring in many solicitations, when you are in your budget, when you have a CI professional, you're required to provide a professional development and mentoring plan for them, right? So the goal here is to incentivize PIs to think about this explicitly, right? And and we are growing this, right? And we've also created awards such as the partnered with DOE on the Better Scientific Software Fellows to again provide incentives and recognition for these individuals. How do we foster a community? Well, we've done a few different things here, right? There's a pilot on minority serving cyber infrastructure consortium. This is just amazing how they brought this community together and have been thinking systematically about how do we recognize and nurture a community of CI professionals collectively across a community of minority serving institutions. There was a solicitation that came out on an RCN. These are research coordination networks. The idea here is, again, explicitly bring the community together across disciplines, across projects to bring CI professionals together. And I really encourage this community to think about responding to that, right? And so this creates a community. And then you might have seen the latest cyber training solicitation, which really had an explicit track, right, for funding CI professionals at the local university and at the regional level, right? And the model there is that we'll fund these with under two circumstances. There is a mentoring sustainability plan for these individuals at the local level, and also a certain percentage of these individuals will be contributed towards a national level support structure, which is then coordinated by the access, and I'll talk about this a little bit, right? So what we're doing is, it works two ways. It provides a resource for training and guiding local CI professionals on, if they have, they need access to certain technologies or expertise, right? You have a broader network, right? But it also provides a national capability that is scalable so that we can meet this really huge and growing demand nationally for this expertise, right? So it's a way of creating a scalable structure for providing that support. And finally, we have another pilot called RCD Nexus, right, led by Dana Brunson and Tom Cheatham, which is looking at understanding what the best practices are and how can universities create the right structures and career paths for CI professionals, right? So they were working as part of CARC, and some of you might be familiar with CARC, right? So now they are trying to build on that and create a expert resource that can work with universities to address these issues and establish best practices. A quick word, I'm sure I'm running out of time, but a quick word on the CI coordination services, and I would say stay tuned, but we're building on experiences that we have with Exceed and thinking about the next step. And there are two guiding principles there. One is, how do we scale to the growing needs, and how do we provide agility, right? So that you can meet local needs, which might be very diverse, at the same time have the global national coordination that you need, right? So this is the underlying idea. And then again, of course, balance stability with innovation, for example, in new allocation techniques. I'm going to hurry up. So again, the goal here is to bring all these things together and to really think of these resources not individually, but as a national cloud in terms of the access, in terms of the allocation, provisioning, execution of applications, and in terms of the support structures, right? So increasingly, we're thinking about this as a cloud. We are envisioning this as a cloud, as an integrated ecosystem, and we are not alone there, right? And I just want to flash this quickly. This is a conversation that's going on more broadly. Sorry. Okay, thank you. So the National NSTC subcommittee is thinking about this. The National AI Research Resource Task Force is thinking about it. The subcommittee on open science, right? So it's really a national movement, right? Let's not think about resources as only compute or only software, as isolated, as siloed, but as a ecosystem that has to be used simply and collectively, right? And how do we make it happen? Again, I would appreciate your thoughts on doing that. A couple of perspectives on major facilities cyber infrastructure at double speed. Okay, so again, this is not something that isn't new to you, right? Major facilities are some of the largest investments with potential for tremendous impact, and CI is central and will only become increasingly central to the mission, to the impact of these facilities, but is also getting complex, right? And facilities continue to find it challenging to keep up with the state of the art. That is what I heard in 2017. That is what I heard in 2019. It just is a recurring thing because, right, you're running already to keep things operational, right? And so it's someone had said you're running to stand still, right? And so if you really want to move and evolve it, you don't have the resources. It's sometimes out of the mission, the scope of the facility. So how do you make that happen, right? How do you ensure that there is fair practices and equitable access, right? And I think this is important. I remember from my days in the facility, right? When we had this great event and data sets coming out, some universities would get access to it immediately. The others would be shipping me a disk and say, please, could you load the data and send it to me, right? And we don't want to have that. We don't need to have that today, right? So how do we make things more equitable, supporting remote users, addressing evolving science requirements, right? Our researchers are trying to do things very differently, combining data from multiple facilities, looking at streaming data, looking at more online triggering mechanisms, right? How do you support those things? So the broad idea here is that facility science should be enhanced, accelerated, amplified using CI. It should not be limited by the CI, right? I should be able to do what I want to do using that facility services and data, right? But not say, oh, I can only do this because all I can do is download the data and then integrate it into my workflow, right? And so how do we enable that? I will skip the animation, but I use this slide because it helps everybody get onto the same page about what is facility CI. And the second message here is that it is complex, right? There is CI that sits on the instruments, that sits on the different experimental systems that has, which is very bespoke, which is very custom from the vendor. Then there's facilities CI that sits within a facility. This is your data lifecycle management, data processing, data product generation, metadata generation, data cleaning, right? Also the accounting and reporting software. And this really is an important part of it and requires understanding best practices, whether it's on the enterprise scale system management, whether it's cybersecurity. There is cyber infrastructure that the scientists use, whether it's their local resources or national resources. And then there's the cyber infrastructure that just connects all these together, which in my mind is often missing, right? How do we connect these different pieces so the science users can really use it in a more seamless manner? So given this framing, I wanted to leave you, and this is my last slide, with a few questions, right? When I'm thinking about cyber infrastructure, right, and given that facilities are very, very diverse, right? Every facility has some unique requirement, but there is also a lot of commonality. What are the right metrics? And are these metrics relevant to those different life cycles, right? For example, we can talk about performance, whatever the performance means. We can talk about security. We can talk about openness and reproducibility. We can talk about equity of access. We can talk about sustainability. We can, and so on, right? So there are a lot of metrics into understanding what that means from a facilities perspective, and when to apply is important. How can we infuse CI considerations across all facilities, across all the life cycle stages, right? And what does that mean? Clearly, the cyber infrastructure requirements are going to evolve, right? But what does it mean to be thinking about cyber infrastructure as a first-class design requirement, right, when you conceptualize it, rather than an afterthought that I've seen in many facilities, right? Some are, every facility is different, but you see it often, right? This is, folks hadn't really thought about cybersecurity when they're thinking about it. They hadn't thought about that someone might want to do anything then other than download a netcdf file. Why would anybody want to do anything else with that, right? The only modality sometimes is to go to the portal and download the data, and that creates obvious inequities in access, right? So how do we think about it? How do you maintain an evolutionary mindset, right? One thing we know about technology is that it's going to change. We also know that about science needs, right? So how do we think about it right from the beginning that this is going to evolve, right? So how do we bring that in? I think the last two are really interesting from my perspective. How can we better align what we're doing in the broader science investment, cyber infrastructure, and what the facilities are doing, right? For example, if we know we're going to build these large facilities, how do we make sure the cyber infrastructure is there and they're complementary so that they can really connect and really accelerate, amplify each other, right? And then that's true for services and expertise as well. And then finally, can we think about CI facilities, cyber infrastructure is a portfolio approach, right? Why does every facility have to understand how they need to manage bits and bytes in the data lifecycle, right? Can they be cross-cutting services like we do with CI Compass, like we do with Trusted CI, with ResearchSoc, right? We've been able to create cross-cutting service. Can we do it for more, right? Why does everyone have to figure out how to move data or how to engineer a data delivery mechanism? Are they cross-cutting? And what are these, right? There are clearly some things that have to be specific to a facility, but there is a lot that can be cross-cutting, right? But is this an opportunity, and what is it? Right. So I'm hoping I'll get some answers to these in the discussion here. I'm really anxious to talk to you individually, or collectively about this, but I think we really have to see how we can move facilities, amplify their impact, democratize access. And I think CI is going to be critical of that. So with that, I hope I'm not out of time. And if I apologize, and thank you.